Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I would like to invite you to an example of distribution filter loading. And to do so, I chose this exercise. The idea here is to measure the contributions of both sources S1 and S2 to the load connected at point P. I am going to read the exercise and show you step by step the solution. Let's go to it. A 1 km long distribution feeder with resistance but negligible reactance is fed from both ends at 13.8 kV by a redundancy loop departing from different substations. The feeder supplies concentrated loads of unity power factor as shown in the figure. The question: calculate the contributions of source 1 and source 2 at point P. Okay, my friends, this is the question. Now let's go to the solution. At first, let's take as our reference S1, okay? And let I1 be the current coming from S1 and I2 the current from S2. And R is the resistance per meter of the feeder. Alright? We are going to sum the voltages and voltage drops along the feeder, okay? From S1, our initial reference, to S2. Let's do it. 13.8 kV is the voltage here. Is equal to the voltage drop along this portion of the line, okay, this segment of line. And the voltage drop here is, as we know, resistance times current. Okay, but what is the resistance? The resistance is 400 meters times the resistance per meter. Okay, so it is 400 meters times the resistance per meter. And the current in this segment here is I1. Now let's calculate the voltage drop along this segment here. The voltage drop is going to be the resistance, which is 200 meters times the resistance per meter. And the current is going to be I1 minus 200 amperes, okay? Because part of I1 goes to this load, so it is I1 minus 200 amperes. Plus, similarly, the voltage drop here is 200 meters times the resistance per meter. Times the current, which is I1 minus this part here minus this part here. Okay, so it is I1 minus 300. And the voltage drop along the last segment is going to be 200 meters times the resistance per meter. Okay. Minus times the current, and the current is I1 minus this part 200, this part 100, this part 200, which is I1 minus 500. And we arrive at S2, and the voltage here is 13.8 kV. Now we have our equation that will enable us calculate what the problem wants us to calculate, the contributions of both S1 and S2 to the load connected at point P. We can cancel these terms out and develop this, okay? It's gonna be 400R I1 plus 200R I1 minus 40,000R plus 200R I1 minus 60 times R plus 200R times I1 minus 100,000 R equal to 0. You see that all the terms have R. Then we can simply cut here, okay? And we have only now terms with I1, okay? And from this we get that I1, okay, it is easy to develop this, and we find that I1 is equal to 200 amperes. Okay, this is the current that leaves this bus here and goes to the feeder. And since the current supplied at point P, is okay, this current here is 200 amperes, but 200 amperes goes to this load. Then we conclude that I minus 200 is 0. So source S1 does not provide any current to the load at point P. All the current from S1 goes to this load here. And what is the other conclusion? The other conclusion is that S2 is the one that provides both currents here, 200 amperes and 100 amperes. And this 200 amperes comes from S1. Okay, there is an alternative method to check this. We are going to use this now just to verify if this is indeed true. Okay, and this method to verify is to use S2 as a reference rather than S1. Okay, we are going to use now S2 as a reference rather than S1 to check if our result is true. Okay, we are going to sum the voltages again, but now backwards from S2 to S1. And at first, this voltage here, 13.8 kV, which is going to be equal to the voltage drop here, which is 200 times R, okay? The resistance, 200 meters times the resistance per meter, times this current I2. The same will be applied to this segment here, which is going to be 200 R times I2 minus, now it is not I2 fully, it is I2 minus 200 amperes, the current that flows along this segment here. Okay? This segment is going to be 200 times R. Minus 300 amperes. 300 amperes. And along this segment here, it is going to be 400 meters times R. 400 meters times R. Times I2 minus 500. Okay, 200 with 100, 300 with 200, 500. And this plus the voltage here, 13.8 kV. Again, we cut this with this and we multiply here and we get 13. Okay, this we have already cancelled out. We are going to do this 200 R times I2 plus 200 R times I2 plus again 200 R times I2 plus 400 R times I2 plus negative 40,000 R plus negative 60,000 R plus negative 200,000 times R, and this is equal to 0. Okay, now we develop this, we cancel the R's because there is an R in every term. We can cancel when this situation occurs, and then we find, developing this, that I2 is equal to 300 amperes. We are interested in knowing the contribution of S2 to this point here. S2 begins with 300 amperes. This current here, I2, the contribution of S2 begins as 300 amperes. 200 amperes goes to this load and the rest 100 amperes goes to this load. Okay, then we have proved twice using two different methods, one coming from S1 and the other coming from S2, to prove that this source here does not provide current to point P, but this source here provides current to this point here. Okay, this current 100 amperes actually comes from source 2. Okay, my friends, this is the video that I wanted to make. I hope you guys liked it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye.